Okay. Yeah. Can you see my screen?
Yes.
Great.
Yes, yes. The
Okay.
Harry Potter one.
Yeah, because we're gonna talking about magic. So okay. Hello everyone. My name is Quipper, and yeah, I'm gonna talking about refactor with magic. But we are not going to become just like Harry Potter to remember some spell and using it, or using a magic one. We don't need this, but we want to create the spell itself and using it to refactor our codes. But before we start to create our spells, we need to understand about AST first. Is abstract syntax tree, because we will using it to understand our code and refactor it. And AST is actually just a representation of our code with tree model. So, for example, if we have a code like this, uh, basically this is a just string, just a text, but how the IDE actually now understand about the code, like how the editor can know this variable declaration, and how the editor now this is the function or something. Yeah, that's why we need to understand what AST first, and some of the benefit we can get after now about this. Let's go to I have example here. For example, this one, for example, uh, there's a tree model that we can understand what the code. For example, we have a function foo here. It's a function, and then inside of the function is we have if statement and return statement. And with this tree model, we understand there is no else, just if and then return if false. And inside of the if statement, we have binary operation. It's a x greater than 10, and we have block. And inside of the if, we have uh, declaration, variable declaration a and equal to 2, and return a multiplied by x. It's like let's try to write it. For example, we have function foo here, like in the example, and then uh, let's have if x greater than 10, and then we have var a, let's say equal with 2, and then uh, a x, or return x plus 10. Now this is the AST model. Yeah, AST. We have function declaration here, and we understand in here the name of the function is foo. It's using identifier. It's like a variable. And we have parameter here. This is an array, so we able to add more than one. Now it's x, and then we have body. Inside of the body, we have if and return statement. So it's like this. In the inside of the if statement, we have a binary expression. Its operator is greater than, and then the left side is x, and the right side is 10. And yeah, and then we have a block statement here. Inside of the if, we have variable declaration and returns. And variable declaration is var a, and then assign it to 2, and return it as a binary expression again. It's with multiply left and right. The left is A and the right is X. So this is three model from our code. So we able to find or do something to the code, because if we just get this like just a text, it will be hard to do something with this. It's like if we want to as a compiler, for example, how we understand or identify this is a function. If it's just a text, it will be like regex or something. It will be heavy. So we need this to parse. I forgot to explain this. In JavaScript, we have some parser we can use. Usually maybe Babel parser, or we have Acorn. In this case, I'm using Regex because I will using just Kotlin, this library to transform the AST. So I'm gonna uh, change the or update uh, this structure to become another one. For example, to become arrow function maybe, or something, or class. And we have just go to more example. This is simple example. For example, uh, hello world or hello mom. uh, yeah, console log is expression statement. We have uh, expression, call, and then object, property. The object is console, the property is log. So with this AST, we understand yes, a console log is actually just an object with property function. We can prove it. Let's go to console. So if we understand what the AST, we can understand more about our code. Like this. And this is an object, and it have a lot of property here that we able to use, not just log. And then yeah, we can see this is the structure from console log. And in this we have literal. I mean the value is the parameter argument. Say hello mom. How about alert? I'm sorry. That's hello dad. This is expression statement too, but it's different, a little bit different. It's have a color directly and name. There is no object. It's directly using name. So after we understand this, we can do something. For example, I'm gonna try to refactor. For example, this is uh, we want to remove all of console log from this code. That's get more more. We just need to understand. We want to find. So first thing that we need to do is find the code that want to refactor. Is expression statement. For example, here is console log. So we just need to add expression statement here, and then we able to do something like we can replace it or remove it. For example, uh, we already remove all of the expression statement, but in this case we just want to select the console log. So we able to do filter here. So the filter is start from this one. So we going to write the expression. We find the different. The different is the color is object. So we can do this. object, and then the name. The name is console. Now we got it. But how if we have one here, for example, and we just want to remove console log? So with this structure, we understand the difference is in the property. So we can add property here, and then the name is log, and we got it. If we just want to remove warn, console warn, we can change this. Yeah, and yeah, we're able to remove it now. How about alert? If you want to remove alert, just go to see how this alert. This alert is expression and then Kale and then directly using name. So we can remove this and just using alert here, and we get it. We remove it. This is a simple one, and this is so useful because, for example, in learn or link in our code, we have a lot of console log, then we want to remove it. It is hard if we remove it one by one manually. So this is how we can do to replace it instead of find with this tool. Yeah, and how about I will add more example. This is a complex one. For example, I want to convert this function to become arrow function. So we need to understand the structure of arrow function first. For example, we have same function here, and let's see. Arrow function is no function declaration, so it's different. It's a function. It's a variable declaration, and instead of variable declaration is have arrow function here. So with this AST, we understand. So arrow function is not start from this. It's just a variable declaration like usual, like what we do in here. But in this one, we understand arrow function is start from here. So that means arrow function is anonymous. There is no name for arrow function. And how we convert this? So we just need to refactor this function declaration to become arrow function and variable declaration. For example, we gonna find the function declaration first. For example, and yeah, we get it because it's removed. And for example, I have two functions. For example, say hi here. We just return hi. And we want to convert it to become this. So we need to do for each first because we want to add get the each body from the function. So we have pet here. Pet is the result from find. So we able to do pet gpet, and then now we able to replace it. Now we need to rewrite with this structure. For example, in here we have variable declaration. So variable declaration, and we need to have kind. The kind is cons. So it's cons, and then we need to have a variable declarator, this array, variable declarator, inside of the variable declarator is identifier. We need identifier. We just get from path that we have first. Path node is start from this path node. So we need identifier. So we just go to here. So path node and ID, and we got it. We got the variable for now, and then we need to go to the body. The init is arrow function. So arrow function, and in the arrow function we need to have a parameter. We can get from this one. The parameter is path, node, and params. And then we need to have the body. Just go to here, path, node, to body. And now we get it. We refactor all of the basic function to become arrow function. And yeah, if we change this, for example, let's follow this refactor. So yeah, we don't need, if we have so many files and we want to refactor it, this how we can do. It's like what Eslin or Lin do to fix our code. This is how it works, and it's good for a library. If we have a library and we have breaking chance, we able to create code mode. We usually call it code mode. For example, Next.js here, Next.js have code mode. In this one, code mode. For example, in Next 10, they are adding import React from React in the all of the component files. So if we have 100 file and we want to add this, it will be hard. But we just need to run this, and then the just let's say, for example, just add this code to all of the component that we need to add. And this is the biggest one. This is CRA to Next. So if we have a Sierra project, it will be converted to Next.js automatically. And so many example, for example, React code mode to convert class component to become function component. For example, this pure component using arrow function. Yeah, without directly touching the code, we just need to run this code mode, and then let's this transformer refactor our code. So I think that's all from me. Thank you.